Welcome to Math 104. We are working with average error and regressions with Desmos. So first we want to start with opening up Desmos in your graphing calculator. And one thing that is unique with Desmos, make sure you, if you are using Desmos frequently, I would highly suggest making an account with them. That way you can actually save any sort of changes. So once you start like entering in formulas, you can go ahead and hit save. And I'm just going to write this one as average error and regression. So I'm going to go ahead and hit save. You'll notice over here it has average error. And then if you click out, it'll have some of your other saved graphs. Sometimes it has examples. And so I'm just going to click out. So first thing we're going to do is click on the top left corner where it says the plus sign, and then we're going to go down to the table. Now in our data, it's already given it for you. So we're just going to enter it in as we see it. So we have 1, 2, 3. And notice that sometimes it'll pull up already with the value that it believes you want. So you can go ahead and hit enter as long as you're keeping track that it is the same. And then we have 6, 8, 12, 14, and 18. And as you're graphing, you'll notice that some of these values are popping up on your coordinates over here. Now, these are going to be your actual values. So what we're going to have to do is find a good window by adjusting the windows on the tool setting over here. So taking a look at your X and your Y values, we're going to go ahead and make that adjustment. So notice that your X values are going from the values of 1 to 5. So when you do make that adjustment, notice that your X values over here, we don't really need to go all the way out to -10 if we are starting at the value of 1. We don't also want to start at 1 because then that's cutting off a point. So something along the lines of kind of close to your 1, but not on it. So -1, -2. If you wanted to start at 0, that's fine. I might honestly adjust to -2. We don't need to go all the way up to 10 either. Perhaps we stop at 8, or if you wanted to stay in 10, that's okay. Now your steps is referring to your scale. You can leave it as blank, or you can actually put in a value. Going from -2 to 8 isn't a whole lot of values that are in between them. So I might keep it at 1 or just leave it blank. Same thing with your Y's, looking at 6 to 18, right? 6 being the smallest and 18 being the biggest. We don't need to go all the way to -15. So perhaps we do -5 this time. They don't need to match your X and your Y's. We can adjust it. And notice that here it's going all the way up to 15, but we do have the value of 18. So we do want to be a little bit larger than 18. So probably 22, 25. And again, looking at the values from -5 to 25, there's not a whole lot of space between those. If you wanted to go up by something larger than 1, perhaps 2 would be good. Let me click out when we're done. And if you don't want these minor grid lines on there, you can take those away. I'm going to keep them because I think they look a lot nicer. And notice here that you do have a good view of your graph. If you wanted to see your graph in total, you can just click that button that you just saw me do, and it looks like this. And at this point, we do want to evaluate what graph would be a best fit. So if we're kind of looking at these dots, they kind of line up in a straight line, which is what we're going to be doing here in a moment. So we're going to be generating a regression function. So in another cell, so perhaps over here, clicking at 2, we enter in the following formula. Because we can kind of tell this is in a line, we're going to create this equation of a line. So we're going to write y, and it's going to be a lowercase. As you're going through, it's going to be very sensitive if you type in a capitalized value. Now we want to write a subscript of 1. So this is referring to the y1 here that we're going to be entering in. So to hit the subscript, we are going to be holding down your shift function and then the dash symbol. 1. And then our next value that we're going to hit, it's that little squiggly line over here, which is typically found up here in the left corner. So we're going to go ahead and do that. And again, you're going to hold down your shift button as you're doing it. So hold shift and then click up here. That's what these values up here are. As you've noticed, if you want to get to the top values, you're just going to hit shift and then the one that you would. Then we're going to click A, X with that subscript again of 1. This is going to refer to this X1 column plus B. Now, when you have entered it in, you'll notice that this pops up right away. So it says parameters A equals 3 and B equals 2.6. And this is actually referring to this particular line. So when I go to ask, now write the equation, you're going to actually type in or write y is equal to 3x plus 2.6. That should be the line that you enter in right here. Now what this is doing, if we click out of it, you'll notice that this has created a line that is getting as close as we can to these points. This is called the line of best fit. Now we're also going to be taking a look at r and r squared, right? What is r and what is r squared? So we're going to be using r a lot more frequently than r squared. This is called your correlation of coefficient, whereas the other is called the correlation of determination. So r, when we have it, we want it to be as close as positive or negative 1 as possible. For us to be a positive 1, it just means that your line is going up, or if it's a negative 1, it is going down. And even better, the closer we are to either 1 or negative 1, the better, because it just means that this green line is hitting each point directly. So right through the center, it is the best fit possible. Now looking at our R, it's 0.9934. So it is very close to a positive 1, which means that these misses are actually relatively small. So this is going to be a good fit. It's not a perfect fit. I don't want to say it's an excellent fit by any means, but it is a good fit for our purpose. Now, if you do have r squared and not r, what we're going to have to do is just undo the square by taking the square root of it. So that concludes the regression portion of it. Now let's go on to your average error. So we're going to go ahead and turn on your residual plots. We're going to be looking at predicted values. So we're going to be taking a look at this equation and seeing how well it fits to your y values that are actually given to us. So let's go ahead and click on your residual plots here, and you'll notice it adds a few more dots. Now what this is doing is we want to get as close to this x axis as possible. And notice that it's, again, getting pretty small. We're not so far away from your x-axis. It's just reflecting as how close these x values are, or sorry, these y values are to your y value of your line. So once we do turn it on, you'll notice that this new column is going to come up. These values here are just telling us how close your predicted y values from your line are to your actual data. So the smaller these numbers, the better. So in a new cell, so in cell 3, we're going to be typing in this formula. Now we want to make sure that we're not capitalizing anything that we don't see capitalized over here. And then whichever your subscript is in, so for example, if you are plotting multiple regressions on one and decide to plot your residuals, you'll notice that these subscripts are going to change. So make sure you're selecting the correct subscript that you would like. So we're going to type in S, SE. Again, these are the only values that are going to be capitalized, is equal to total, parentheses, E with the subscript of 1. This is referring to this column right here. So again, if you had multiple columns, it would show up as E subscript 2, E subscript 3, and so forth. We're going to click out, and then we're going to square this value, and then type in a parentheses. So what this is referring to is the errors, the average amount of error that has occurred. Okay. So now let's take a look at your average error. So now squaring all of these errors. So again, we're going to type in the equation that you see here. Make sure you're not capitalizing anything that is not capitalized already. To type the square root sign, you're just going to type in SQRT, and then we're going to have your average error. So we have A subscript E is equal to, so just type in SQRT. I'll do that again because my cursor was in the way, SQRT. And then we have SE divided by count, parentheses, X sub 1, that is referring to your, what is it called? Your X coordinates right over here, close parentheses. Now this is giving your average error. So the smaller this value is in comparison to the values here, the better. So if you had much larger gaps in between your X and Y values, or if your Y values are really, really large, obviously the gap between them is going to be larger. So if you're seeing numbers that are a lot larger, that's okay, as long as they fit the big scheme of your data. So ours only going up by very, very small margins, the smaller this number is better. Now with that in mind, again, if you're going to decide to plot multiple equations into one, because you can fit as many equations as you would like. For example, if I wanted to plot a quadratic, I would type in the following equation, y sub 1 ax squared, ax, I actually like to do my subscript first, ax1 squared plus bx subscript 1 plus c. So you'll notice that there is a new line that gets created. It gives you a correlation of determination. However, we do not want that value. We would typically want the just the r. So just taking the square root of it. And then you'll notice that it does fill in with your A, B, and C. Now let's say I didn't want to graph it against this line. I can just click out of that so that I'm just seeing your plots right here. Then if I wanted to plot x2, or sorry, E sub 2, notice that again, it pulls up this second category here. Let me make it a little bit larger. And if I wanted now the total for your second residual, all I would have to do is change the subscript, and then that would pull up the error for your quadratic. And that's about it. So just keep in mind, these are our other our other ones. If we are talking about, let's see, wanted to say it was exponential, or it could have been logarithmic. We're going to have to do one extra step, but it's just very small. So definitely hang in there, watch the remaining videos where we talk about quadratic, cubic, quartic, and the remaining.